Hi everyone, my name is Vinicius. I'm from Brazil, specifically from Rio de Janeiro, so I'm a carioca. Today I'm 18 years old and my project is Seebeck-Watch system for wristwatches based on temperature difference and thermoelectric films. My advisor is Marco Rogério Vieira, co-advisor Michael da Silva Santos, and another big help that today I have and extremely important for the project is from Metalmatch, Engineering Institute of Material Science and Metallurgy. But probably you are asking yourselves, Vinicius, how did you start with the project? And I answer you, Vinicius is a person who is very concerned with the environment. And when I discovered that 1% of total garbage around the world is from batteries and piles, and primarily I use the device that most use these batteries, I think, oh my god, I have to do something to change the situation. Because another thing that 82% of people around the world discard that on environment or in a common garbage that affects the environment in a better way. So I think and propose my goals that first is build a system for wristwatches based on elaboration of thermoelectric things in bracelet form, besides to electronic circuits, and third the circuit will be able to work in front of little temperature difference, enable the highest switching interval of batteries in the system, and to conclude, decrease the utilization of thermoelectric materials in big portion because we have a lack of these materials. In relation to the methodology, what is the reason to choose some material methods, starting with the thermoelectric system? I have chosen the smooth tolerance based on antimony and selenium on account to the highest value of the Seebeck coefficient and the value of the figure of merit at room temperature in the unit. That's one of the goals, get the better results in the end of the application at room temperature. Besides, we have the flash deposition, that's a technique to deposit the material, and it was chosen because the cheap price of the application and get the better results compared to all of the literature that have been written before. The annealing is a technique to improve all of the results of the properties that's intrinsic all of the materials. So that's the point. And to continue, we have the Clapton tape, that's a surface to deposit the material and chosen on account primarily to the low thermal conductivity to get the better results and don't make the starting conditions influence on the result and the condition and the elaboration and preparation of the circuit. To conclude, I have assembled the heater based on copper and titanium to the thin film as a form to keep all of the heat junctions warm on account to the high thermal conductivity of the copper in the center of the thermoelectric film, getting all the heat from the human body and make the biggest temperature difference from the human body and the environment. Now, to talk about the electronic circuit, starting with the 1-volt converter LTC3108 as a form to transform 20 millivolts that's from the temperature difference in 3 volts or in maximum. But in conjunction to that, we have the transformer LPR6235 and the rechargeable battery from Seiko that is described below, because when we are on summer or in the train we have a little temperature difference between the human body and the environment. So to make this downward application and the working of the circuit, the battery was charged during the time that the circuit is okay, and when it's not okay, the battery is working to make the application work in any condition. And to conclude, we can see the architecture of the thermoelectric film in the right side, such as to the out view of the thermoelectric film, and to finish, we have the number of joints in each bracelet that varies from 165mm and 196. Continue with the methodology. As I have said before, all of the preparation, the methodology of the thermoelectric film, based on hours, was analyzed to the literatures from Takashi 2008 and 2010 to get the per results of the temperature range of operation, critical temperature difference, electrical resistance of each semiconductor, and the difference of electrical potential and current in function of the temperature difference, because it has similarities on account to the application, to the process of operation, the materials used in the application. So it has a lot of similarities, so we can gather all of the informations to get that information and that results based on calculus in relation to our methodology and in relation to the grain thickness, electrical conductivity, Seebeck coefficient, thermal conductivity, figure of merit, based on, I have said before, The literature is from Takashi in 2008 and 2010. So now talk about of the electronic circuit methodology. Basically, it was divided in two phases. The first related to LT-SPICE, a virtual simulator that ensured that the end of the application will be in the correct way. The second, and as shown on the right side, the schematic of the LT-SPICE. And the second related to the final prototype of the electronic circuit, as shown on the left side of this slide. And in both situations, were accomplished all of these tests that's proposed in the first, the charge distribution and alimentation of whole circuit, the second, correct output the current in each component, and to conclude, the charge and discharge time of battery and durability. This moment we reach the best part of the presentation. That's from results, and I will go ahead to operation of thermoelectric circuits. That's basically most of the time the circuit will be working and every bracelet in the perfect way and in any condition, minus during 33 and 37 Celsius degrees, primarily because in this time, such as in the summer, and the circuit won't be working. But to talk about a human, I don't even meet anyone that can be in this situation, 37, 35, 36 degrees. So you will be in the last temperature, so the circuit will be working correctly, or in emergency cases, the battery will be working in this way, as it will be charged previously. So to see it more precisely, it is yet a function of critical difference of temperature that varies from 0.61 to 0.51. And there is another big point that's from the electronic circuits, the durability of battery, discharge time, and the charge time. But starting with the discharge time, we have 220 hours. That's too much when we charge all of the battery we have. These two use the system, so that's too much. And the durability of battery that most impressed me, because we have 129 years to 323 years. That's too much. There is no human that survived for all of the time, so we can put out and go down of the discharge of the battery in the environment. And you can see on the right side of the slide the output and current of each bracelet and the function of temperature difference from the thermoelectric system. So to conclude everything, there is another good point that's from the cost of the electronic circuit plus the thermoelectric system. That's basically the price is $10.86. That's too little compared to the application of Power Watch. That's the basic watch is $100. So compare everything, you are reducing 10 times of the price. So that's perfect and to sustainability too. So to conclude everything, the thermoelectric system will be working, which is working, the electronic circuit too, as I have said and shown before. In the next steps, do some analysis with the thermoelectric system to conclude everything, and I have acknowledgement to do for you that have been read all of my project and watched my video, and a phrase made by me, that is, science transformed my life. I don't say it in a cliché way, but yet I speak of my intrinsics. So basically that, greetings from Brazil, thank you for watching.